Welcome to the Explainer. So today we're going to dive into something really cool, how we can make our data way smarter. Basically teaching it to understand the messy, complex, and nuanced world that we all actually live in.
All right, let's kick things off with a question. It seems simple, right? But for a computer, it's actually kind of tricky. So how would you categorize a 45-year-old employee? Are they young? Middle-aged? What's the right box?
Okay, so you see on the left, a traditional computer gives what we call a crisp answer. It just looks at its rules and boom, sticks that person right into the middle-aged box. But the thing is, reality is way more nuanced, isn't it? That's where the fuzzy answer on the right comes in. It reflects that messiness. It says, hey, they can be a bit of both, mostly middle-aged for sure, but maybe they still have some qualities of a younger employee.
So, this whole conflict, between our neat digital boxes and the messy real world, it's actually a massive challenge in data analysis. And it really all starts with a concept called a data warehouse.
So what is a data warehouse? Well, the best way to think about it is like the official history book for a whole company. It's this giant central library where all the important info from every department, sales, marketing, HR, you name it, gets collected, organized, and stored. And that's what companies use for all their big picture analysis and strategic planning.
But here's the problem. This history book is written in pure black and white. It takes something that's continuous, like age, and just crams it into these super rigid, inflexible categories. I mean, look at this table. It says that at 466 months old, you are officially young. But just 1 month later, poof, you've crossed this hard, invisible line, and now you're middle-aged. That's just not how life works, right?
Okay, so what if? What if we could teach our data to see the world differently? Less like a bunch of on-off switches and more like, I don't know, a spectrum of colors. What if we could actually teach it to see all the shades of gray in between? Well, that's the core idea behind a really powerful concept called fuzzy logic.
And you know what's crazy? This isn't some brand new idea. Believe it or not, we're talking over a century ago. Even Albert Einstein was pointing this out. He basically said that trying to force the world into these neat, precise boxes is often just, well, it's far from the actual truth.
So what fuzzy logic does is it completely changes the rules of the game. It throws out that classic all-or-nothing approach. The idea that something is either 100% true or 100% false, 1 or 0. Instead, it says something can be like 80% true and 20% false. And if you think about it, that's much, much closer to how our human brains actually work.
So, let's bring it back to our employee example. Instead of someone being rigidly in or out of a box called experienced, fuzzy logic lets them belong to multiple categories at the same time. They could be, say, 70% experienced and 30% medium experienced. Now that is a far more realistic and, frankly, way more useful description, right?
Okay, I know what you're thinking. This all sounds great in theory, but how on earth do we come up with these percentages, right? How do we calculate that someone is 70% experienced without just, pulling a number out of thin air?
Well, the key is a pretty cool mathematical tool called a fuzzy membership function. Now, don't let the name scare you. Think of it as the rulebook. It's just a formula that takes an input, like a person's age, and then it calculates how much that person belongs to each of our fuzzy categories. It spits out a value between 0 and 1 for each one. But here's the catch. For a long time, most of the research in this area kind of cheated. It relied on human experts to just subjectively define these functions. They were essentially guessing at the rules. But, and this is the really exciting part, the work we're looking at today introduces a super clever, data-driven approach that lets the data itself write the rules.
And it's called the box plot method. What it does is it uses a totally standard statistical tool, you might have even seen one before, it's called a box plot, to analyze the data and find the natural boundaries and transition points that are already hiding inside it.
And the process is actually pretty straightforward. First, you just partition your data, maybe split it up by year. Then, you create these box plots for each chunk to see the data shape and make sure it's consistent. And then, this is the magic part, you take the average values from those plots and use them to automatically define the rules for your fuzzy function. The data does the heavy lifting.
And this is what you get. It's this beautiful, nuanced model built directly from the data. It now understands that these categories actually overlap. A person's age doesn't just fall into one box anymore. You can see how someone at the far edge of young also starts to belong a little bit to middle-aged. The model sees that transition for what it is, not a hard cliff you fall off, but a gradual slope where you can be part of both.
Okay, so this is all very elegant and clever. We have this data-driven way to see nuance. But let's get down to it. What's the real-world payoff? Why should a business actually care about any of this stuff? Well, the implications are actually huge. We're talking across a ton of different industries. Retail, customer management, HR, financial services, even healthcare. Really, anywhere you're dealing with complex, messy human behavior, this applies.
Let's make this real with a retail example. Think about a product like coconut oil. A standard old-school data warehouse would look at it and force it into one and only one category, probably cooking.
But a fuzzy warehouse, it can actually reflect reality, which is way more complex. It understands that people use coconut oil for a ton of different things. It might find that, yeah, it's 58% for cooking, but it's also 27% for cosmetics and even 9% for religious uses. Now that gives a business a much, much truer picture of who their customers are and what their total market really looks like. And the exact same logic applies to human resources. Instead of just slapping a blunt label like high experience on someone, you get this incredibly precise and useful profile. Here, the analysis shows an employee is about 61% medium and 39% high experience. I mean, think about how critical that kind of nuance is when you're making big decisions about who to promote or how to build the perfect team.
So you might be wondering, how much better is this really? Well, the study that came up with this method actually tested it. And they found their fuzzy model was nearly 70%, 69.7%, more aligned with a real-world, nuanced understanding of employee experience than the old, rigid way. That is a massive improvement.
So, when you boil it all down, this isn't just some abstract technical exercise. It's really about making our business analysis fundamentally more honest. It's about creating a model of the world that is way more accurate, way more nuanced, and just far more reflective of how things actually are.
And that really leaves us with a final, kind of provocative thought to chew on. What other crucial insights are we missing right now just because our data is stuck in black and white? What else could we possibly learn if we taught our data to finally see the world in all of its beautiful, messy shades of gray? Thanks for joining this explainer.